Hello, my name is Jeff Jennings with Equilibar, and I would like to talk a little bit today about flow control using back pressure regulators.
Traditionally, flow control is achieved with linear or rotational actuators. They are typically limited to flow ratios of 10 to 1 or 15 to 1. In today's demonstration, we're going to use the Equilibar back pressure regulator to control flow across a 100 to 1 range. We start by using a constant pressure supply. This could be a pump or a pressurized header. In this demonstration, we're using an air over water tank delivering water at 50 psig. In this experiment, we will be measuring and controlling water flow from 1 g per minute to 100 grams per minute. This flow rate will be measured using an Endress and Hauser Coriolis flow meter. Back pressure regulators are normally not used to control flow, but they can be easily configured to do so with the addition of a flow restriction such as an orifice or valve. In this experiment, we'll use a needle valve adjusted to produce about 130 grams per minute of flow with a 50 psig differential pressure. The back pressure regulator will be used to modulate the flow by reducing the pressure drop across the metering valve. For example, when the back pressure regulator is controlling its inlet at 40 psig, then the metering valve has only 10 psi differential, and the flow rate will be at about 36% of full range. When the back pressure regulator has 48 psig at the exit of the metering valve, then the flow rate will be at about 8% of its full range. Equilibar back pressure regulators control their inlet pressure to be exactly the same as the air pilot pressure on their domes. Because there is no friction or hysteresis, Equilibar back pressure regulators respond to pressure changes as small as 1 part in 10,000. We are using a QPV electronic pressure regulator to supply the variable air pilot pressure to the Equilibar back pressure regulator. Like the Equilibar, the QPV is a high-resolution device capable of resolving air pressure to 1 part in 10,000 as well. A controller using proportional and integral control is used to adjust the back pressure regulator to quickly converge at the desired flow rate. In this experiment, we'll demonstrate moving through a wider range than is possible with mechanically actuated valves. There are several benefits to using a back pressure regulator instead of a mechanically actuated valve. 1. The flow control is not dependent. 2. The diaphragm is the only moving part in an Equilibar regulator, making our designs simple and easy to maintain. 3. We have Hastelloy and PTFE regulators available for highly corrosive research applications. And we offer models up to 300 bar and up to 300 degrees Celsius. Here we have the flow system controlling at 1 gram per minute. This corresponds to a higher back pressure with less differential pressure across the metering valve. The PID controller keeps the loop in balance by adjusting the electronic pressure regulator. As we adjust the flow set point up to 20, we see the PID loop calling for decreased back pressure, and we see the flow rate increasing to 20 grams per minute. The mass flow meter stabilizes at the higher flow rate, and increasing flow further up to 80 grams per minute easily produces consistent results. While this demonstration is based on very small flow rates, the same concept can easily be adapted for systems with much larger liquid or gas flow rates. Contact an Equilibar application engineer or visit equilibar.com for more information.